So this project that I'm going to share today is very much about using open data and making it more accessible. I actually work at Sidewalk Labs, which is an urban innovation company, and I work on a software product there called Delve. And one of the reasons I went there is because I'm really interested in making data more accessible to the general public and stakeholders in general. And Sidewalk Widths is really a story about taking open data, which is free and available from NYC Open Data, and presenting it in a new way that makes it more accessible to the general public. And so today, the talk is broken into a few segments. First of all, I'm going to give a 10-minute presentation about the project. Then I'm going to give a 20-minute demo, which just shows the whole process that I went through to get the open data from NYC Open Data and then turn it into an interactive website and put it up on GitHub. So it's going to be a demo, like a walkthrough, and I think I gave out directions beforehand, so you can follow along if you want. But if you don't, you can just watch. And I think there's some interesting information for anyone who's interested in using GitHub and creating open source projects. And so this project started a year ago, shortly after the pandemic started. I was working at Sidewalk Labs, and as soon as we went into lockdown and started working from home, Sidewalk Labs gave all the employees Wednesday afternoons off to give back and volunteer to the community. And so the way that I chose to do this was essentially creating a map of sidewalk widths for New York City. And the reason being is that pretty early in the pandemic, the CDC came out with guidelines about social distancing and maintaining 6 feet distance from other people. And so urban dwellers, especially in New York, who are brushing shoulders with hundreds of people a day, usually just on their commute. All of a sudden, they became hyper aware of qualities of the urban environment and how it impacted their ability to maintain social distance. And so sidewalk widths was one of these. And as you know, New York City, it has varying sidewalk widths throughout the city. So old districts like the financial district with narrow streets, like Gold Street, have some very narrow sidewalks, and other places that were much more intentionally planned, like Harlem and Malcolm X Boulevard, have some very wide sidewalks. So I went into this knowing there was a lot of variation. And of course, once the pandemic hit, the sidewalks started being used for numerous things. So this photo is from the summer on Smith Street in Brooklyn. And now you have things like streeteries and outdoor dining and all these activities that are vying for space on sidewalks, which makes an understanding of sidewalk widths even more important. And so whenever I start a data project, I generally, if it's in New York especially, I generally start on NYC Open Data. It's just has so many different data sets that are easy to access and download if you know a little geospatial software. And so pretty quickly, I found this Planometric sidewalk data set, which has the outline, so the shape for all the sidewalks. The thing it doesn't have is the width of the sidewalks, which is the key piece of information for judging social distancing. And so the challenge here was figuring out how to actually measure these really complex shapes. You might think a sidewalk is simple. It's just a straight line along a street. But once you get to places like Central Park, which you can see on the left in this image, the pedestrian footpaths actually get quite complex. So my role at Sidewalk Labs, I'm a senior computational designer, and so I spend a lot of my day working on geometry algorithms, and this seemed like a really interesting problem to solve. And so I ended up coming up with a solution that involved finding the center lines of these planometric sidewalk shapes. And once I could get the center line of these shapes, it was actually kind of simple just to measure back from the center line to the closest point on the outside of the shape and multiply it by 2, and that gives you the width in that particular place. And so this is showing the process. And in order to make this data accessible to the public, I created an interactive web map that's at sidewalkwidths.nyc. And so you can definitely go there and check it out if you'd like. And so this interactive web map, it allows you to navigate and explore New York City. You can zoom out and see the patterns of sidewalk widths across the city, or you can zoom into a very specific street and hover over the sidewalk and actually see the width of the sidewalk in that location. And then you can see, in this example, the sidewalk's 12.7 feet. I added the color to the sidewalk width, as well as an indication of how difficult it would be to maintain social distance on that sidewalk. And that's based on the width. And so after I made the site, the first thing I did was tweet about it. A lot of the people I follow on Twitter and a lot of my followers are part of the New York City citizen mapping community, along with people in New York City Planning Department. And so the project ended up getting shared quite a bit. And I got lots of responses from people that live in New York, people that were doing some ground truthing and confirming some measurements or talking about construction or changes in sidewalks. And because the data set is from 2014, I think, from some aerial photography taken during that period, it's obviously a bit out of date. So had people commenting on that as well. I also had some people that were commenting on the UI and the design of the app. And so I ended up changing the app and redesigning it in response to some comments that people had as well. And also even adding new features based on some requests. So things like this histogram and this filter feature. Also via Twitter, the map got in the hands of the Department of City Planning in New York, some organizations like Transportation Alternatives and DOT. And so I had people from these agencies contacting me, requesting the data in different formats and looking for pointers on how to use the data. The great thing about that is that the map ended up being used in a city council meeting as justification or part of the justification for the Open Streets initiative in New York City, which ended up passing in city council and over the course of the past year has closed in close to 100 miles to cars so that pedestrians and cyclists can use them. So yeah, that was a super exciting outcome of this project. Another part of this project is I posted it on GitHub, which I'm going to be talking about a bit more today, but GitHub is a platform for collaborating on coding projects. So things like websites or other types of coding projects. And you can post projects to GitHub and make them open source so anyone can download them and use them as their own. So I made it open source and posted it on GitHub. So people from all over the world started copying the project. So literally copying the code onto their own account, which was the intent, and then creating their own versions of the map. This was super exciting. I ended up working with some of them, helping them through technical issues, and also people contributed back to my map as well. So throughout this community, there was some mutual helping in setting up these maps. But for some of these maps, I didn't have any part in it whatsoever. I didn't talk to the people that were building them. They just started appearing just because it was on GitHub and it was open source. And so I can show you, this is another website I made, which compiles all of those projects. So there's New York City, that's the one that I made. And then people made them for cities all over the world, like Sao Paulo, Berlin, Washington, DC. And even Italy was an interesting one because they ended up greatly advancing the version that I made and creating a version of the map that could work for all of Italy. And the version I made, it's only capable of really representing maybe one city, but they made some technical improvements to their map so that you can view the whole nation, which is really awesome. Yeah, so I will show you the New York version very quickly. So you enter the map. There's a window here that pretty much explains that the map is intended to give an impression of sidewalk widths. And there's a disclaimer about not using this map to really inform trips, which is pretty important because it is out of date and the accuracy of the map is dependent on that aerial flyover done in 2014. So it's really not a present day example of what the sidewalk widths are in the city. And so you can open the map and you can explore it by zooming in, and you can zoom in, you can either zoom out and look at the change in sidewalk widths across the city. So you can see in the outer boroughs, you can see that sidewalks are getting pretty thin as evidenced by the red color. Then you can also zoom into specific streets and actually hover over those streets. And so blue and green are very wide sidewalks. And then as you go to yellow and then orange and then red and then this dark pink, the sidewalks get thinner and thinner. And I think I'm going to conclude the presentation part there, and I'm going to move on to the demo. I'm going to explain how to download this data onto your own computer and essentially get a website set up and working. So essentially, you're able to work with and manipulate the same code that I wrote in order to create your own version. So this is going to be about 15 to 20 minutes. It's technical, but you can just watch and follow along and learn about the different tools that I'm using. If you want to copy the Sidewalk Widths project for another city, say I know Boston is another city that has a planometric data set. I've lived there before, so if I was interested in doing that, the way that I would do that is actually from this website, from the landing page. I can just go to the GitHub page here, and essentially that takes you to my GitHub. So you can see this is my username and this is Sidewalk Widths NYC. I put a lot of information here. I talk about the methodology, so how the sidewalks are actually measured. And then down at the bottom, I have this bit on how you would actually copy it and work on it on your own. And so in GitHub, there's a really important concept called forking. And so if you fork a project, that's when you take someone else's project and you make your own version of it and that you then own and can work on. If you create a GitHub account, you can fork all this code. But you don't even need to have a GitHub account to download project and start working on it. All you need to do is go to this little green button right here on GitHub, and you can download it in different ways. So you can download a zip file. So that's one way if you wanted to follow along with it, you could download the zip file. You can download GitHub Desktop, which is an application for working with GitHub. Or the way that I'm going to show you is using the software Git. So if you're following along, I asked you to download Git, and so we're going to use that method. So the first step here is downloading it's called a repository. So it's all the data that I produce. A repository is just a set of folders and files, just like on your own local machine. Probably you have a file system. How I'm going to start is by going to the folder where I want to save everything, so where I want to download it. And I'm not going to do it in downloads because I want this to be a more permanent home for this repository. So a lot of people set up, they just have a folder on their computer called GitHub, and everything they download from GitHub, they put in that folder. And so that's what I'm going to do. If you have Git, a good way to do this is you can right click just in that folder. At least this is on Windows, and you can run git bash out of this folder. If you're on a Mac, you can search for git bash as well, which should come with Git when you installed it. And then it's quite simple. You just go to this green button here. You can copy this address, go back to git bash, and you just type in git clone, and then you can paste that link that we copied here in that button. And then you're going to put it in a folder that you can name whatever you want. So widths -NYC Open Data, and that starts copying all of the code from the project. If I go back to my GitHub folder here, you'll see that now I have a new folder called Sidewalk Widths NYC Open Data, and that's where all of this data is being downloaded. So here you can see the same folder structure on GitHub. It's all now on my own computer, and I can use it however I want. Now that we have all the code, the first thing I'm going to do is show you how to actually measure sidewalks. The process of measuring sidewalks is done in Python, which is a really versatile programming language. And if you wanted to make your own version of this map, you don't even really need to use Python. I wrote all the Python code, so it's really just a matter of running the code and to create your own version. So I'll show you now how to actually go ahead and run that Python code. This is the perhaps most difficult part that involves opening Jupyter Notebooks. So I'll show you how to do that. That's the software. So another thing I asked you to download if you're following along is Miniconda, which is a software for running Python code. So if you search for Miniconda then and open it in your search bar, you can open up the Anaconda prompt. And then within here, this requires a little understanding of the command line, but really all you need to do is type in cd and then go to your GitHub folder. So type in cd space GitHub, and that will bring you into your GitHub folder. And then from there, you can cd into whatever folder you made. So I made one called Sidewalk Widths -NYC Open Data. So now we're actually in the same folder here. From here, now we need to run Python. Another thing I asked you to do if you're following along is to set up a virtual environment. A virtual environment is just a way to manage your Python install and download different packages that you need in order to run the code that you want to run. And if any of you are familiar with geospatial software like ArcGIS or QGIS, Python has specific packages that you can download that are essentially, there's something like QGIS or ArcGIS. They're essentially code that you can use, like pre-written code that you can use in Python. I asked you to install some packages, the way that you actually get to your virtual environment. And I think you've already done this, but if you're following along. So if you type in conda and list, if you're following along, you're using this open data environment. And so you can just type in conda activate. And then you can see here that it says open data. And now you can just type in Jupyter Notebook, and that is going to open up the software called Jupyter Notebook, which allows you to run Python code. So again, you can see that same file structure here within Jupyter Notebook. So you can see the files you downloaded from GitHub. And then within this folder structure, I have a folder called Notebooks. So if you just click that, and then there's a Jupyter Notebook file within that folder. And then if you open that, you'll see that there is a notebook that I created. And this notebook, it looks a lot like the GitHub page. It has these images of the sidewalk widths. This notebook essentially lets you run the Python code. It also explains what each bit of the Python code does. So it lets you annotate the code really easily. Essentially, if you're trying to recreate this data, if you're trying to recreate it for another city, for instance, like let's say Boston, there's only one thing you need to do. You just have to swap out this sample shapefile here by downloading a shapefile from, let's say, Boston's Open Data website. I'll show you how I found the sidewalk data for my website on New York. Is really, I just typed in sidewalks and NYC Open Data, and it brought up a whole list of different things that might be related to sidewalks. And so it took a little bit of scrolling and reading through. Down here, there's the data set is just called sidewalk. There's also sidewalk centerline, but I used sidewalk. And so you can click that link, you can open it. And NYC Open Data is great because they have a map that's interactive where you can view the data. You can see here that same data set that I used. That's the planometric data of sidewalks. And in order to download a shapefile, which is a geospatial file, you just go to export, and then you can select this shapefile option here. That's what you're loading into your Jupyter Notebook. Really, the only thing you have to change here is you have to download that shapefile and change the name of it here to whatever you downloaded, and then you can import it. Or if you're following along and you downloaded all the data from my GitHub, it comes with a sample shapefile that's already working in this notebook, so you don't need to do anything. All you need to do is go up to the top here and click run and run through this code. So this code, it will load that shapefile that has the geospatial information, and it'll present it for you. So right now I'm just rerunning it, so the images look the same. So this code goes through a bunch of processes to start interpreting and analyzing the data to get the widths. And so you can see these blue progress bars here that will let you know how the progress is going. And so it shouldn't take very long. As I was explaining before, we get the center lines of each of those sidewalk shapes. Next, we remove the short ends. You can see that these center lines are pretty messy. And then finally, once we have a cleaner version of those sidewalk center lines, and then we actually measure the sidewalk widths. And so if you keep on clicking run at the top of this notebook, it'll just take you through all of those steps. So I'm just going to run through them. Here you can see in this last image something similar to what's in the map, where the sidewalks are colored based on their width. You only need to run down to 31st cell here. And this one actually writes out and saves a GeoJSON, which is another geospatial file format. So essentially we loaded a shapefile, which is one geospatial format, and we're exporting GeoJSON, which is another format that's a little more friendly for working on the web. So if we go back to that folder where that we downloaded from GitHub, if you go into that notebooks folder, you'll see that notebook file that we opened using Jupyter Notebook. And there's also now an output here. It's called output.geojson. If you want to, so GeoJSONs have become a favorite geospatial format for the web. And if you ever want to see what a GeoJSON file looks like, a great website to do that is called geojson.io. So this is just a handy tool. You can just click and drag a GeoJSON file into this map here at geojson.io, and it'll just load that file for you. So you can see here that there's a GeoJSON file with all the lines, all the center lines. Okay, and then at this point, we've downloaded the GitHub data. Then we downloaded Open Data, a shapefile from Open Data, and processed it and actually got the sidewalk center lines and measured them. And we got our output file. And so now the process is just taking this output file that we can see here and inserting it into the web map that I already made. If we go back to the folder where we downloaded the GitHub data, if you're familiar at all with basic web development, you'll notice that this folder structure represents a basic website. So you can see here there's an index.html file. So this is a website, and it has everything that you need in order to create the same sidewalk widths website that I built. So you'll notice with a lot of static websites, sometimes you can open an index.html file, and that's the case with this one. You just double click on it, and you can see that it brings you to something that kind of looks like the website, although it's missing quite a few things. There's no map in the background. You still have these tabs here, but nothing's quite working. And that's because This website interacts with Mapbox, and then Mapbox is a free web mapping tool that lets you create styles and create web maps. And it's a really great tool to learn if you're interested at all in making web maps. But because this website needs to interact with it, you actually need to create a secure server for interacting with Mapbox. It's pretty simple to do that. All you need to do is open up the Anaconda prompt that we opened before to run Jupyter Notebook. If you click Control-C or Command-C on Mac, we'll shut down Jupyter Notebook, which was that application we were running before. And now when you're in the same folder, so you're still in Sidewalk Widths NYC Open Data, from there, all you need to do is type in python-mhttp.server. And this essentially is a built-in server that comes with Python. So it comes with the Python language when you install it. What this does is it lets you run essentially a web server from your computer, which gives you a way to securely talk with other websites, which is important for working with Mapbox. So if you type that in, you just press enter. You'll see here it says serving HTTP on port 8000. What this means is that your computer has a port called 8000 where the website is being hosted. You can actually go back to your browser. You can create a new tab. And if you type in localhost 8000, that's going to take you to that website. However, you're noticing that you still can't see the map in the background. And that's because Mapbox requires user-specific tokens in order to access their API, which is essentially how you interact with Mapbox as a service. The last thing I'm going to show you is just how to configure Mapbox in order to allow you to display the data. If you go to mapbox.com, I think if you're following along, one of the things I asked you to do is create a Mapbox account. So you should go to mapbox.com. You should probably be signed into your account. Once you're in your account, you can go to this upper right-hand corner. And you can just click Studio. And so Mapbox Studio is how you create tokens that allow you to use and access the Mapbox service. From here, we want to go to actually account, I believe. Yeah, so account has some of the access tokens that you need. And the one that we're going to use today in order to get the website running, it's called default public token. And so essentially, you can just copy this to your clipboard, and back in the Sidewalk Widths folder downloaded from GitHub, you'll see there's a number of subfolders. One of them is called JS, which stands for JavaScript. So you can just open this up. And I made a easy settings.js file here, which is a way that you can actually add all of your tokens easily. If you can open that with a text editor, it could be like really any basic text editor will do. I use Atom, but people also like Sublime Text. There's also like Windows or Mac specific ones like Notepad. So I'm going to open this using Atom. In this file, I created a bunch of places to add these Mapbox tokens. You're going to want to put your default public token here just by pasting the one that you copied. And then it's also asking for a couple other things. It's asking for Mapbox style token as well as tile set and layer. And so it's really these four that we need to change in order to get the website working. Fortunately, back on my Git, if you remember, I gave these directions for forking. And so this is a good guide for how you can actually fork the data, or as we did, download it to your computer and then get it working. We added our default public token for Mapbox. The second thing we need to add is a style. I give a link here for that same custom style, which is essentially the background of the map that's used in the website. And so you can actually click that link. You can go down to the bottom right here and click copy. What that does, if you have a Mapbox account, is it will copy that style to your account. And so now you can see that style layer, that base map on your own account on Mapbox. So you'll see there's no sidewalk lines here. This is just the base map. Now that you have it on your account, you can publish it. You can just click publish, or if you click share in the upper right-hand corner here, that's where you can access the token for that style. You want to go here to the style URL, click copy, and then this Mapbox style is the thing that you want to change here. And so you're updating your style. And then the last two things you want to do is add your tile set. So the tile set is actually the data that we created. So we went through the Jupyter Notebook, and in the notebook folder, we created this output.geojson. And so this is what we want to upload to Mapbox. I'm going to go back to my Mapbox account. Now I'm going to go to Studio this time in my account. I'm going to go to tile sets up in the upper right-hand corner here. This is where you can upload thematic data for a map. The Mapbox style is how you create the base map. And then the tile sets is how you add thematic data, so things like the sidewalk widths themselves. All I'm going to do is click New Tile Set up here, and then I can drag and drop output.geojson into that menu and click Confirm. And then down in the bottom right here, you can see that Mapbox is uploading and processing that sample for that output.geojson. So it's still processing. It actually gives you this code here, though, and this code is what you need to copy. If you go back to the settings file, this is what you need to paste, and this time you're pasting right here. There's one last line, the fourth line, that you need to update as well. If you go back to Mapbox, you need to go down and find that tile set that you loaded. This is the one we just loaded here called output. So click on that, and you can see under this layer details section, there's a code here. So if you copy and paste that, then your map should be ready to load on your own computer. So at that point, you go back to localhost 8000, where we're hosting the website. You can press enter or refresh, and you'll see it might not actually load everything the first time. What you need to do is open up your browser's development tools. On Chrome, they're in More Tools, and then you click Developer Tool. Go to Network and disable this thing called cache. So cache is just the first time you open a website, it's going to download some data to your computer so that you can go back to that website and essentially load the same thing more easily. But in this case, it saves the fact that we didn't have the correct tokens. You reload again, should work. It's taking a while to load. I think it's working. I think the internet is just being really slow. Here, just to make sure, I'm going to actually close this and try starting my server again. So I'm just going back to the Anaconda menu, click Control-C. I'm just going to run python-m http.server again. Last time it was on port 8000. This time I'm going to do 8002. We're not running on 8000 anymore, so localhost 8002. So now it's working. By changing those 4 lines in the settings file, you're loading your map. As you remember, we only process that little bit of sample data, and so that's the only bit that's loading here. So this is the data that we processed in the Jupyter Notebook. Yeah, now we have a working web map with data that we processed on our own. This is now a website that you can host on the internet anywhere that you want. There's a ton of different hosting platforms, and you can share your data interactively with anyone in the world, which is really powerful. And I'm going to conclude the demo there. I know it's technical, but we recorded this. So if you ever want to follow along and do this on your own, the recording is available. Yeah, so I'm concluding there and opening up for questions. You can ask general questions about the project, or if you have any technical questions as well.
Thanks, Meli, for that demo. We do have 2 questions that came into the chat as you were presenting. The first one is from Tom, and the question is, would it be easy to add categories of condition and wheelchair accessible to the width variable?
Let me actually show you one more thing very quickly. If we go back to the settings file that I showed you, we can actually change the dimensions that we're using and also change the color and the annotation. So I'm not sure in terms of wheelchair accessibility which one would be the dimension, but we could just change the text. So here we would say it may be possible for, 12 feet, possible for, or it's somewhat difficult for people walking. And then if you're in a wheelchair, it might be, you can add something like wheelchair impossible. You can save this file. And then if I go and I just refresh this map again, then I go back to this legend here. It actually says somewhat difficult at 12 feet, but then it says wheelchair impossible. And so you can update all these annotations. You can update the dimensions here. And so it's all customizable.
And there was a second question from Tim asking if you could share feedback from other cities' applications of the sidewalk widths that were noteworthy.
The app that we're currently looking at today, it's actually not the first version. I updated it multiple times based on working with other cities and what they were finding. One of the main things is because this was being implemented outside of the US, where the metric system is being used. I also added a setting here where you can change it from feet to meters, and that way you can adjust based on the context that you're working within. Other things is people were really interested in viewing the data based on different districts. And so this is something that they wanted to do in Sao Paulo. So this is a functionality that I added to New York and that they found very useful in Sao Paulo for their own purposes. And yeah, the exciting thing is about implementing this in other cities around the world is that each city has its own story of the kind of impact that the map had. And so in Italy and especially in particular Milan. The map was created by an advocacy group that really wanted to do something similar to New York, where they would open up streets to pedestrians and cyclists. And so they used the map as kind of a central piece in pushing through some legislation to end up closing a number of streets in Milan.
We had another question that just came into the chat from Rhoda. Have you thought about marking locations of street trees or street furniture? These occupy the walking space of sidewalk.
That was definitely something that I considered. And I know the street tree census for New York City, they did a great job at actually measuring all the planters where the trees are. So you can actually subtract those from the sidewalks if you want, the planometric data set. And I ended up not doing that just in order to keep it simple. And that way other people can copy it, because that data is probably not available for really any other cities. The street tree census is something very specific to New York. So instead, I opted for this Likert scale of difficulty. That is quite not super specific, like the range from very difficult to somewhat difficult. It reflects the fact that at 15 feet, it says somewhat difficult. 15 feet is a lot of space to have in between two people, but there's a lot of uncertainty in the sidewalks and obstructions that are there, whether it's planters, whether it's outdoor dining, or whatever else. So I opted for going with a Likert scale with some more vague descriptions of what dimensions mean, rather than trying to model the streets really accurately, because it's impossible to get a super accurate model of the streets. That's a really good question. And a lot of people on Twitter were like sending me photos of like pinch points on the sidewalks where it's super narrow, and because you have all these obstructions. So it's definitely something that's important.
Oh, another question from Tim. What was inspiring to you working on this project?
So the most inspiring thing is how many other people there are out there that are really interested in mapping their cities and advocating for change in their cities. I've just talked to so many people from all over the world from this project. Essentially, they were new to web mapping, new to coding, but because I made it so simple to replicate with a little help, they were able to copy this for their own city and use it for their own purposes in that location. So that was just super inspiring to see how you can connect with people based on mutual values and mutual interests like this. I think we can conclude it there then. Does that sound good?
Thanks for joining, everyone. And thank you so much, Meli, for the really thorough and very clear presentation.
Yeah, thanks so much for joining.